In this video, we will start with double angle formula. You will find this on page 450 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Let's start. Double angle formula. The formula for sin, then it's now 2a, cos 2a, and tan 2a. We can derive the double angle formula from the compound angle formula, the previous videos. Okay, so how do we derive sin 2a from sin a plus b, the compound one? So use the compound for sin. Okay, let's start. Just write it in there. Okay, there it is. The one can you remember the sin? It's sin and cos, cos and sin. Okay, and the signs, if this is a positive, this stays a positive. Now, replace b by a in the equation. Okay, so every time you see a b, you're just going to substitute a. Then I have sin 2a, and this will give me, do you see this is exactly the same because it's a positive, so it's 2 sin a cos a. Very, very easy. Okay. Then we go to the next one. So sin 2a is 2 sin a cos a. Now, derive cos 2a from cos a plus b. Okay, so start again. Cos a plus b, can you remember? So it's cos a cos b, signs are different, negative sin a sin b. We do exactly the same. Replace b by a in the equation. So every time we see a, we are just going to, okay, this gives three forms. So every time we see a b, sorry, I was too low. Every time I see a b, there is the b's, I just put the a. So it's going to be cos 2a, okay, so it's cos a, so what's cos a times cos a? I actually could have write that step in. I'm just going to show you quickly. It's not necessary, but just for the video, I think it's good that I write that step in there. So you could have just said cos a plus a. Okay, it's actually there that it must come in. And then plus, okay, equals cos a, cos b, a, minus sin a, sin a. So every time I see a b, I put a, so this is going to be cos, do you agree? Okay, there it is. So it's going to be cos square a. Okay, there actually I wrote it. Okay, I was thinking I left it out, but I wrote it there. Did you see? Okay, so it's cos square a minus sin square a. But this is interesting. This one was just having one form, the sin 2a. But this one is actually having three forms. So I know that from my normal identities that cos square a is equal to 1 minus, because remember, sin square a, Pythagoras, plus cos square a, identities, is equal to 1. Okay, so cos square a, if I take it over, then it's going to be 1 minus sin square a. There, I replace that blue. Did you see? And then I repeat this. And this is going to be 1 minus 2 sin square a. Okay, so there's the other option. There I showed you with 2. But let's take again. I can also take and substitute in the place of sin square a. I know sin square coming from the same is 1 minus cos square, and if I substitute it there, so it's negative, positive, and then it's cos square a plus cos square a, which is 2 cos square a minus 1. And there is your three options. Okay, so I'll show you. Sometimes you will use this one, or this one, or this one, depending on the question. And then the final one. Okay. So in the final one, okay, where am I now? I'm going to derive tan 2a from, again, the compound a plus b, tan a plus b. Again, write it down. Can you remember? Signs the same, it's different. and then it's tan A plus tan B, 1 minus, and then I multiply the two top ones. Okay, again I do the same. Replace B by A. Okay, so I write A. There I did it. Then it's tan A plus tan A, that's 2 tan A, and this is 1 minus tan squared A. And there again is your formula. Okay, I'll show you now on the worksheet. Let's just go to the next one. I said it to you that they will give you a formula sheet in the test or in an examination. I'm just going to make it a bit bigger, and I'm going to show you where. Where is my double angles? Okay. So there was still a compound, and here is my double ones. Do you see? Do you see that cos 2a is having 1, 2, 3 options? But sin 2a is just having 1, tan 2a is just having 1. Okay. Now, I'm going to make it a bit smaller, and I'm going to start with the sums. Okay, let's look. Now, usually what I do is I first get you used to working with the formulas. So, usually they will not ask it in terms of expressions, but more in terms of equations. But it's very good practice, and you have to start on this level and get used to the formulas. Okay. So, given that sin A is 4 over 5, and A is between 90 and 180, very important. So it's actually like I'm saying all this is first blocked out. Okay. Find the exact value. So sin is opposite over hypotenuse, and with Pythagoras theorem I find this 3, but don't forget it's on this left-hand side, so this side will be negative 3. Okay, as indicated there. Now, let's start. Sin 2a. Now, what is my formula? And I can just go there. Do you see it? So it's going to be 2 sin A cos A. Because remember, this graph is just for A, not 2A, just for A. So this is the graph for A. So then I must first get rid of the 2A, break it up according to the formulas into the A, sin A, or cos or tan, doesn't matter. And then I can substitute. And then I can say sin is opposite over hypotenuse. There's where and then what is cos? It's adjacent over hypotenuse. And then this is over 1, and then I can just multiply it. So this is 2 times 4, it's 8 times 3 is 24, and then this is also 5, it's 25, and that is the final answer. Okay, let's do the next one. So the first 2 is actually very straightforward. This last 2 is a bit more challenging. Okay, so tan 2a, again, I'm going to look for my formula. Where is my tan? There it is. Do you see that? So basically, I'm just going to break it up into 2 tan A and 1 minus tan square A. Okay, again, I have tan opposite over adjacent, so it's negative 4 over 3, and I substitute, and I basically just simplify there. Did you see? So I got negative 8 over 3, and I got, remember this is going to be positive 16 over 9, and if I subtract this, then it's going to give me that, okay, I want to just show you here. Okay, so this would have been 1 minus, and remember, 4 times 4 is 16, and 3 times 3 is 9. Okay, do you agree? And then you can take your calculator, your ABC, use that. So say 1 minus 16 ABC 9 equals, and that's where I got the negative 7 over 9, and I'm going to multiply with the reciprocal there. It's very easy. So it was negative 8 over 3, multiply the negative 9 over 7. And then that's where I got, it's became a positive 8 over multiply 9, 3 multiply 7, and that would be my final answer. And that, if I simplify that, 24 over 7. So you can, if you press that, if you say 72 and 8 times 9, remember 8 times 9, and then you press the ABC, and you press 21 equals, and shift ABC if you want to make it improper. Otherwise, you can make it a mix. It will also be correct, and that will be 3 and 3 over 7. Doesn't matter. Okay, now we come to the more challenging things. Now, the problem is I don't have a formula for 4a. I have 2a, 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 not that is double angles. 4a not, but I make a plan. So what is the plan? I know that 4a, in the double angle, if I take 2 and I take the double angle and I times it with 2, then I will get 4a. Did you see there? So basically, I'm taking the formula. Okay, and I want to show you nice and clear. So, and I'm going to write this step in here. So it's like I'm doing this. I make it 2, and then I say 2a. So every time I see, I'm first going to write the formula down, okay? So it's going to give me then, okay, now remember it's sin. Can I just show you where is sin? I'm going to clean it first, that you see better. Okay. So I'm with sin. Let's see what's sin 2a. There you see it. There you see it. Okay. Now, every time, so it's like I'm writing 2. I write the formula, 2, and then I write sin. And then in the place of a, I put every time 2a. Okay, do you see that? And then I'm going to write cos 2a. And it's almost like this 2 is just in front. So actually, it's like when I see a, I just substitute it first with 2a. Okay, we will now bring the other things in. Okay, so basically, now don't forget. Now I'm sitting with sin 2a as well as cos 2a. So I'm sitting again with the double angles. So in the place of sin 2a, I'm now going to write that. So in the place of sin 2a, I write 2 sin a cos a. 2 sin a cos a. And then in the place of cos 2a, okay, let's just see. If I see this is in sin, so I try to keep into terms of sin. So let's see, I think with this one will work the best. And then it's just one, not cos, not the one that's both, but if I substitute that one. Remember that cos 2a is having how many options? 3 options. Okay. So basically, I'm just putting in that one. Did you see that green one? And now, my whole thing was that I must end with an A, and an A, because then on this graph, I can just work with either sin A, I can get cos A, and I can get tan A from the graph. But now I have that. So now I'm going to write sin A. So what is sin A? Sin A is going to be opposite over hypotenuse. Okay, what is cos A? It's adjacent over hypotenuse. And then 1 minus 2, what is sin? And remember it's squared, so it's opposite. It's 4 over 5 squared. And I basically just simplify that fraction. And that is my final answer. Okay, let's look at number D. Now number D is saying to you, okay, let's just mark it, tan a half A. Okay, but I want to work with the double angle. So what I'm going to do is I know that if I take a half A, if I multiply it with 2, then I will get tan A. Okay, so basically I'm going to take this one and I'm going to write it in here. It's actually tan, are you with me? And it's 2 because I want to come to the double. But now I'm just going to substitute a half A. But now I can use the formula. Okay, because what is the formula of tan? There it is. So that is going to be equal to, and remember to substitute the half. So it's 2 tan a half A over 1 minus, okay, let's just go, tan square. And then a half A, sorry, my pen. I think if I put that step in, it will make more sense. So it is the double, I use the double, but there's the 2. So now, if I multiply this, I will get A. Okay. Now, why do I want to get A? Because I said to you in this graph, I can work with tan A. So if I can substitute this tan A from the graph, I can say tan is opposite over adjacent. So it's -4/3. And I have that. Now first I'm going to simplify. Because at the end I just want to end with this. So, and I have halves there, but I must simplify. So I cross multiply. That's what I did there. Then I multiply, and I get this. Then I divide 2, just trying to simplify. And now, oh, this is nice. Bring this one over, and I have a quadratic trinomial. Did you see that? Okay. Now I'm going to factorize. This is in group B. This is a negative. So it's 2 and 1. Okay, just get the pen correct again. And because it must be 3, 1 and 2. Because 4 minus 1 is 3. The biggest overcross gets a negative positive. And don't forget that it's tan a half A. So it's going to be 2 tan a half A plus 1, tan a half A minus 2, the top one. Then I'm going to just simplify, put both equal to 0. I get tan a half A is equal to -1/2. Tan a half A is equal to 2. Now, you must think of chapter 4. Can you remember, and I'm going to take you back to the statement here. Can you remember that if you want to work with now the cost diagram, if this is 1, and if you look here, you have a half. You must first make this interval a half. Now, what did we do in chapter 4? Can you remember what we did? And I'm just going to, I don't want that line, so, sorry. I just divide 2, divide 2, divide 2, because I have to make that a half. Now, if I divide 2, and this is what I show you here, I get 45 and I get 90. I get this. Now I can block out again. Now that, and I didn't show you here, and this is why I'm making the videos, to show you a little bit more, sometimes not so easy in writing. But now I'm going to show you, now it's just going to be between 45, okay, where am I? Just going to be here, it's actually just going to be here between 45 and 90, but that doesn't matter, I'm not asking the angle. So, it's just going to be, let me block it out with another color. It's just going to be in quadrant 1. Now, I look at the two statement equations. This is negative and this is positive. Now, in quadrant 1, tan is positive because all. So what will happen to this -1? Or let me rather take a red. What will I do with this one? I will reject it. That's what I will do. So I'm sitting with tan a half A is equal to 2. And that one was rejected. Okay. It's a bit challenging. That's why I think before you start with the exercise, it will be good that you maybe just try on your own, especially number C and D. Cover it, and see if you come to the answers before you start with the exercise, because it can be challenging in the beginning. Okay, I want you to stop the video and I want you to do try now 13, just number 1. But I want you to do A, B, C as well as D. Again, you can continue the video as soon as you are finished. Okay, let's start with number 1A. I was just copying, so your formula sheet should just know this because this is going to help you. Before we the A, I just want to first do the graph sketch. Given, okay, I can just say that cos A is equal to -4/5, and that A is obtuse. Now, if you have your graph, let's just think. If it's obtuse, remember, in this first quadrant, it's acute. So in the second quadrant, it's going to be obtuse. This is my obtuse angle. Okay. Now, they say, and cos A, so don't forget, cos A, it's going to be, let's just get my pen correct, it's 4/5. So it's adjacent. I will now decide where is the 5. this radius will always be positive. But because it's on the left-hand side of this 0, then this one is going to be negative. And it's a Pythagoras triple. So basically, with Pythagoras theorem, I can just find that this is free. Okay, now I can start. Now they say, the first one they asked you to do, and let's start there, number A. Number A, find cos 2A. Now I go to my formula and I see, okay, so what is going to be cos 2A? Now, take the one that's just in terms of cos, because that's going to be easy. So I can work with this one. So this can be 2 cos square A minus 1. Okay. Now, if I'm going to substitute, then basically, don't forget that this sketch is for A. So this sketch, as I said in the previous videos or in the examples, I said this sketch is for cos 1A, sin 1A, tan 1A. So I have A. So I can basically just say 2. I'm going to just show you if you were choosing, say, another one that you will get the same answer. Okay, but I'll do it now. You can actually even work with this one because you have. So this is the easiest one. So it's negative 4 over 5, and I square and I minus 1. And if I simplify this, it's going to be 2. This is going to be 16 over 25 minus 1. If you put this over 1, so it's going to be 32, ABC 25 equals minus 1 equals, and your answer is going to be 7 over 25. I just want to show you. Say, for example, somebody was choosing the first one. Say this one. Let's see if it's the same answer. If I say cos, okay, I'm just going to say or. Okay, so let's just go. Or, if I say cos 2A, so you could even take the last one also. And somebody was saying cos 2A minus square, cos square A minus sin square A. Let's see if we are getting the same answer. So what is cos? Don't forget, it's negative 4 over 5, and don't forget to square. What is sin? Sin is opposite over hypotenuse, so it's 3 over 5, and what is that? Square. Okay, now let's just go on. So this one will be 16 over 25, this one will be 9 over 25. And if you say 16 minus 9, it's also going to give you 7 over 25. Exactly the same. So even, and I'm just going to do one at a time, so I'll make space every time. Even if you were choosing this one, you will get the same answer. Okay, let's go on. Number B. I'm first going to make space. No, sorry, I just don't want to clean the top. Just every time the A. Because you're not going to work with A in B. Okay, so let's start. Number B. Now, it's going to be tan 2A. Now, again, there is my formula, double angle. So, it's going to be 2 tan A over 1 minus tan square A. Okay, let's just put it in. 2. What is tan? It's opposite over adjacent. So it's 3 over negative 4. Okay, what is this one? This is also 3. Oh, it seems to me the negative got lost here. Okay. Negative 3 over 4. And don't forget that it was square. If we simplify this, it's going to be negative 6 over 4 over 1 minus, this is going to be 9 over 16. And if I simplify it further, and I'm going to do it here, it's negative 6 over 4 multiply. Now, if 1 minus 9 over 16, can you remember? that's going to be 7 over 16. So it's going to be 16 over 7, the reciprocal. And if I say negative 6, ABC 4 multiply 16 ABC 7 equals, and if I want to make it improper, I'm getting it's equal to negative 24 over 7. And if I want to make it mixed, but usually we write it improper, then it's going to be negative 3 and 3 over 7, which is also correct. Okay, that was number B. Now comes the challenging ones. Okay. And again, as I said, this is more to just get you used to the rules. Okay, now number C. Now, this is going to be sin, and now it's a half A. Okay. Now, again, I must think of something. I can use this later. It's almost, when I was using this one, I actually, now I'm going to make it just bigger. Now I'm going to move it a little bit down. Can you remember? In number D, I was looking for tan a half A, but I first end up with this, and there was the half, and later on I came to the half. Now, it's more or less the same principle. I'm going to look now. First, I'm going to recall. I know that if I take, and I'm just going to make it like this. If I take sin, and it's 2, and I multiply with a half A, then I will get sin. Then I can use the double angles, and I will get sin A, which I can use there from the graph. Okay, so I keep that in mind. Now, the problem is also that if I look at my formulas, I will say, oh, there's so many. Am I going to use now, there's not, if I use this sin one, I can, but then I'm sitting with sin and cos, and I have a cos a half, sin a half. There's no method of making that. So I think it will be best if I'm going to work with one, and I'll quickly show you. If I'm going to say cos 2A, because then I can get a half A, it's cos A. And if I work with this one and see if I can, so I'm going to see if I can rather work with this one, so that the sin and the cos is not on the other side. Can you see? It's on different sides. The cos is there and the sin is on this side. Whereby this one, there is the cos, but there's a cos and sin on the right hand. And there's the sin and the cos is there. So I'm rather going to work with this one. So let's see. So I'm going to say sin and 2. I want to come to the double. And then I say a half A. And now, as I recall, I said it's 1 minus 2 sin square. Oh, I forgot. Sorry, not forgot. I wrote incorrect. Why did I write incorrect? Can I show you? It's not sin. It was what was standing there. It's cos 2A. And that's equal to 1 minus 2 sin square A. So make sure you copy it correct. I didn't copy it correct. Okay. Now I'm going to start. So now I'm going to make use of this principle. It can even be cos 2 a half A. Because then I get also cos A. Doesn't matter. So let's do that. Every time I see A, I put a half A. So I make cos 2 and I go for a half A. Is equal to 1 minus 2. And I go, oh, my pen. Sin squared, and I go for a half A. Did you see? So every time I see A, I was just putting a half A. Now, what do I get? So I didn't start directly with this. I was playing around because my whole thing, I want to use my graph. So I want to get one like cos A or sin A so that I can use my graph. I cannot use on this graph cos a half A. That's not correct. Okay. So now I'm going to get cos, and that's going to be A. I already used, there was my identity. So it's A, and now it's going to be 1 minus 2. Keep this. I need that half. I need that half for that. A half A. Okay. Let's move up. Now, what is cos A? It's adjacent over hypotenuse. So it's going to be -4/5 is equal to 1 minus, and now I'm going to just put this 2 sin square of A. Okay. Now, let's just take everything to once. Let's take this one to the other side. Can you see why? Because I don't like that negative. I want it positive. So we take that to the other side. So it's sin square of A. And then take this also to this side, to the right hand. So 1 plus 4/5. So I'm going to get 2 sin square of A, and 1 plus 4/5, it's 1 and 4/5, or I prefer 9/5. Do you agree with me? Okay. Now, I want to get sin square of A alone on the side. So I'm going to go for sin square of A. And now I take 9/5 and I divide it by 2. And let me just show you here. If you take 9/5, you divide 2, it's actually 9/5 multiply a half. So it's 9/10. Okay. So it's 9/10. Okay. Now I'm back at chapter 4. Why? Because we solved this. But before I can go there, I have to go to my question. Why? Just like I showed you, this is a half A. And my question states, my question states that A is obtuse. Do you see there? What does that mean? There's not standing degrees, but that means that A is going to be bigger than 90 and smaller than 180. Okay, because it's in this quadrant. Do you agree? So, and I can just rewrite it here. If A is bigger than 90 and smaller than 180, okay? But remember, this is a half A. So what must I do? I must divide 2, divide 2, divide 2. So therefore, 45, this A, is bigger over 2, A over 2, and smaller than 90. Okay, so in what quadrant is this? So let's just go back. Okay, so if I'm going to continue with this one, I'm going to say sin. And now chapter 4, how do I get rid of that square? So keep it a half. And say plus minus the square root of 9/10. Okay, but if I look here, so it's going to be a positive and a negative. But because of this statement, can I just show you here? I know that it's just between 45 and 90. So it's this just in quadrant 1. Do you see that? So therefore, because what is the question saying? I can just go back to the question to show you. Find sin of half A. So therefore, sin of half A is equal to positive square root 9/10. Because it can only be positive in this quadrant. It cannot be negative. So basically, I reject, let's just say, reject negative square root 9/10. Okay, and that will be my final answer. Positive, or you can leave out the positive, square root 9/10. Okay, so let's look at number D. Cos 4A. Okay, now don't forget that cos 4A is the same as cos 2A. Okay, now if I look at the rules, and I'm first going to clean it, and then I'm going to show you. Now, if I can, and I know the problem with cos, there's so many. There's actually 3. Do you see? It's this one, or this one, or this one. Now, the best will be not to bring in another function. So basically, I look for one. There's a cos and a sin. That's just a cos and a 1, and that's a 1 and a sin. So I think the best one to go for is this one. So, okay, now look. Can I just write the rule first for you down? So it was actually cos 2a is equal to 2 cos square a minus 1. Okay. Now, if I'm going to write 2a, so in the place, I'm just going to write 2a. Do you see? So I'm going to use that rule. But now, in the place of a, sorry, it's not so long. In the place of a, I just substitute 2a. Do you see? That 2 is for the double angle. So I'm going to write, and let's keep it to what? What? So it's going to be cos. Are you with me? Oh, sorry, not cos. It's going to be 2 cos squared, but in the place of a, I just put 2a minus 1. Are you with me? Okay. Now, don't forget that if I'm looking at that one now, that is actually this. What does this mean? And I'm going to write it better. This is meaning 2. Now, let's just get the pen. 2. This is actually meaning, because it's squared, it's meaning cos 2a square. Okay, so usually we write the square there, but it's meaning it's for the whole thing, minus 1. Okay, so if I'm going to now, I look again and I say, oh, but look, there is still a 2a. So let's just go on. So it's almost like I'm going to use this rule again. Can you see? Do you see there? I want to use another color. Do you see? I'm using that again. So I'm writing 2, and then I'm going to make bracket. It doesn't matter what bracket. And then I'm saying 2 cos squared a minus 1. And don't forget your square minus 1. Now, what I was actually trying to do, I'm trying always to get it, and I want to show you here, I'm trying to get it to 1a, 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 so that I can use this information on the graph. So there it was still 2a. After I break it up, then I must use the rule again, because now I'm having 1a. And now I basically can just substitute. So if I'm going to, from my graph, so it's going to be 2, and then it's going to be 2. Now don't forget, that's a, but it's square, so it's 2. So what is, this is a now. So I'm going to say cos, or actually that is the basic angle. So cos is adjacent over hypotenuse. So it's negative 4 over 5 squared minus 1 squared minus 1. And that's 2. And it's 2. And this is 4 times 4 is 16. 5 times 5 is 25. Minus 1 square minus 1. Okay. And that is going to be 2. And now this is going to be, you can say 32 because it's over 1. Over 25 minus 1. And don't forget to square minus 1. It's just simplifying. So it's 32 ABC 25 minus 1 equals, so it's going to be 2, and it's going to be 7 over 25, and don't forget to square minus 1. And if I square that, it's going to be, it's a lot, you could have just used your calculator. So 2, but it's going to be 49 over 625 minus 1. So if I times that with 2, I subtract the 1, but my final answer, it's a negative. It's negative 527 over 625. Okay, so don't forget that this, remember the question, I was actually looking for cos 4a. I'm rather going to say it here. So therefore, because can I go up again? It was cos 4a, and that was equal to cos 2a. So I can end up by saying, therefore, cos 4a, as the question said, is equal to negative 527 over 625. Okay, and because of that, I can just leave it like that. It's not a half, so it's not influencing my degrees there. Okay, and there's also just one option. And remember that in this quadrant, if I look at obtuse, if I go back and obtuse, what is cos in this quadrant? In this quadrant, cos will be negative, as you see in your answer.